All right. Good evening, everyone. Welcome to part two of my combination Springfield and Adirondack civil engineering tour. Yesterday we did most of the rail stuff, some photos from Springfield, Massachusetts, then moving on to an old abandoned missile silo near Plattsburgh. Today we're going to be mainly covering the Champlain Canal lock number 2. As dull as that might sound, it's actually pretty interesting. I didn't even know what was there. I just sort of happened upon it when I was popping by the old the Mechanicville Hydroelectric plant, which I'll also cover in some degree. Anyway, this one should be a bit quicker. So, for those of you who don't know, the Champlain Canal actually is still part of the New York State canal system up there with the Erie Canal. It was actually completed before the Erie Canal, and its commercial success was one of the motivating factors for Erie Canal construction. The Erie Canal, of course, being the major economic opening up, really exploding the port of New York, allowing trade to the inland, the Great Lakes, via everything out to Chicago and the Lake Superior area. To basically, it created both the giant area of Buffalo and allowed that commerce to expand to New York City. Just people don't realize of just how hard it was to move things around in the early American period. You got roads? No, you didn't. Your roads were awful. The interior of the country was pretty much wilderness. If you're going anywhere, it was going to be by canoe, and you had to portage around rapids. Just anything that wasn't by an ocean-going ship was just pretty abysmal in the pre-colonial period. So just to show you where we're talking about here, the one of the interesting things is, though, especially one of the advantages to New York, was that the Hudson River is navigable all the way up to Albany, or even a little bit beyond that. So a lot of these state capitals, you're wondering where, people, a lot of the ones a lot of times you'll hear, well, they pick them to be centrally located, which is, true in some extents, but oftentimes a lot of the cities you see are what they are basically what they say is on the fall line, the place where you have the first waterfall and ocean-going ships can't go. So Albany is that port there. Trenton is basically where the Delaware has the fall line of the Delaware. Baltimore, of course, as far as you can get in. Same with D.C. Richmond, as far as you can go up the James. All the way down, I think Augusta, Georgia is as far as you can sail up whatever river goes to Savannah. There's a whole bunch of these cities, Fayetteville, Raleigh. To an extent, these are all, I'm not sure exactly Raleigh, but there's definitely places where you sail as far as you can go inland until your boat stops. And that's where you have this. You have the coastal cities, and you had this inland string where the fall line was. People might think the Susquehanna is, but honestly, the Port Deposit is as far as north as you can sail there. The second then thing in the early American period was then to put in canals, similar to the ones that have been built all over the UK in the 18th century. The UK, before railroads, was really a canal-oriented country. But in the age where you're looking at oxes and horses towing everything, a canal was like a superhighway. And honestly, someone was telling me about just like the premier canal designer in the UK was an uneducated savant. But really it was just that sort of transportational infrastructure that allowed, because there's very little elevation change in the UK, so they could just put canals all over the place. But the heyday of the canals in this country, since they got a later start in Britain, they were quickly subsumed by the railroads. They got ahead of them by about 20 years. They were competing with them for about another 20 years, and then they were just left in the dust. So where we're talking about today is lock number 2. So the Champlain Canal runs from the fall line at Albany, Rensselaer, all the way up to Lake Champlain. Like I said, it was built before the Erie Canal. The Erie Canal officially starts. Both canals will start at the confluence of the Mohawk and the Hudson. The Erie Canal heading up there's to what today is the route that it took to get up that first major waterfall. That goes to the west. Champlain Canal goes north. I think today you can actually navigate all the way up to the St. Lawrence River. But even just building a canal to the Champlain, Lake Champlain, would get you, a huge amount of interior boat access. And I am pretty sure today that you can navigate yourself all the way up to the St. Lawrence. But again, the draft's not big. You're not getting a big boat up there. The first lock is in Troy. It's run by the Army Corps. That allows. I'm not sure why that's so historically an Army Corps lock. It might have something to do with some military industry in the area, like with the water relay arsenal. But beyond that, you're into the Champlain Canal zone. First lock is right north. We're going to be looking at the second, and the third one is in Mechanicville. I'm going to probably refer to Mechanicville a lot because it's by the Mechanicville hydroelectric plant. It's technically not in it, but that's what I'm going to say. Today, the Mechanicville was part of the large, the easternmost end of the Boston and Maine. That's where they had a fairly large yard that then turned into a giant field and is now a yard again for as an intermodal hub. It's also along this route, actually below where the Mohawk things was the old D&H Colony Shops. That was their main heavy overhaul facility. And there's a lot of other industry in the Hudson Valley. You may have known GE poisoning the river with PCBs and a lot of other stuff in there. So just giving you the idea where it is. So here's the complex. Of course, there's a dam. There's the hydroelectric plant. And there's the Champlain Canal lock. For those of you who don't know, most of the lock infrastructure on these things are effectively parks. You think that they'd all be fenced off or for whatever, but for anything, the canals kind of lost their importance as a major transportation hub years ago. They were expanded for barge access in the 1920s and 30s, and they were used by barging, just like you see in the Ohio, Missouri, and Mississippi rivers. But in the New York system, it just never really caught on in the long term due to the density of railroads and other stuff. So now it's pretty much used by pleasure boaters. It's only open during the warmer months from like May to November. And all the lock areas are both for local people to come and enjoy themselves, or if the boats want to stop and get a bite to eat. Again, you think it's like someone's going to yell at you. But honestly, you can just drive right. There's nothing, unless there's like it's closed for maintenance. You can just usually drive right up, and that's what we did. We were completely, we were sort of surprised. The elevation change here is about 19 feet. It's a low head dam. Some of the dams are more impressive with floodgates and more active elements. The Champlain Canal lock is just basically an unadjustable bump in the river. Interestingly enough, I think that barge marine traffic or interior marine traffic in the United States carries close to the amount, or if not more than the amount that railroads carry. It's easy to underestimate how much and how efficient water transportation is. But it's much, much cheaper to send agricultural products on a barge on a canal or a river waterway than it is to put on a train, especially cheaper than a boat. So here we have the canal, the lock chamber. For those of you who don't know the way locks work, there's a gate at each end. If a boat going up, it enters at the low level. Water is then used to then fill the chamber, floating the boat up to the new level, and then the upstream gate opens and the boat leaves. To descend, it enters, they let the water out, the boat slowly goes down. Pretty straightforward concept. It does use quite a bit of water. Although it's not really an issue here, this was causing issues like in places like the Panama Canal, where each lockage will use crazy amounts of water. Because it's the New York State barge system, there is a yellow and blue motif, which is the state colors of the state of New York. I believe that the dimensions for each of these locks are 300 feet long, 40 feet wide, and they can support a draft of 12 to 14 feet. Here we have the inside of the upper gate. These gates would probably look, if it looks newer than something that was made in the 30s, these gates do get replaced on a fairly regular basis, or at least a basis. This is clearly welded, not riveted. I doubt that there'd be any original gates left. They are generally watertight, but not entirely watertight, and it doesn't really matter. I was recently at some on the Erie Canal. And in winter, when it's drained, it's even more sort of spooky looking. Just because the things look a little bit. You take away 14 feet of water, and everything looks a little bit bigger. So here's one of the mechanisms to open the gate. The newer ones that they're updating now with the newer mechanisms use hydraulics. The older ones use an electric motor, a motor and drive system. You can see the clutch there, and the thrust and the sort of the bearing. So to clutch it in and out, that lever moves that collar engaged with the teeth. And then that begins to turn it, and that rotates this arm, and that opens the gate. I don't know if the gates are improved by being hollow and buoyant in some way, like if they're filled with air to make them lighter. When built in the 1810s, this would have been of a typical very small canal towed by mules, maybe about 10, 12, something like 10, with the very tiny little canal boats, 10, 20 feet wide. And like I said, it was upgraded for barges in the 1920s. And then it was used mainly for commercial service up into the 70s until the decline in boat transportation turned it into a more summer pleasure craft thing. I had friends who bought a sailboat in Canada and sailed it down via the Erie Canal from Lake Erie. So we have the buildings. The one there, there's the tender works in the small modern shed. The larger, older looking one is actually where they have the old electronics and is sort of what they call the powerhouse. You'll see why in a little bit. For these, I would be looking. So this is actually at the upstream side. I'm there. I'm looking this way, sort of northwestward. Again, here we have the Lowhead Dam. Looking across it. The Hudson can get some pretty crazy water flow going on it. This was a pretty sedate day. I don't know. I think in the summer dry seasons that this can really start looking, trickly. The priority uses for the water are going to be going through the powerhouse and then to a degree the canal. So in the summer this can be completely dry, but there's still the majority of the river flow could be going through the hydroelectric plant. Most of these dams that offer the locks do come with hydroelectric power stations, at least the ones on the major rivers. This just shows why they would choose the locations, they would tend to put them at where there would be naturally occurring waterfalls. So here we can see a remnant of the old waterfall at the east bank. And here we have another photo inside the locked chamber. This was taken, like I said, this was October, so very close to the end of the season. I think it's May to November. I don't know if it's a date, if it's May 1st through November 1st. There was not a lot of traffic going on at this point in the time of the year. And like I said, the rise is 19 feet. Or 14 feet. C2. Lift or drop 18.5. So here, in addition to opening and closing the doors, you needed pumps to open and close the valves. Here we have one such valve head with an electric motor running it through the bearing box. The motor controller in these large vertical boxes. As the motor controllers have been swapped out for more modern ones, they have tried to keep the look the same, which is nice. Well, again, when the locks are all drained, you can sort of see into where the valve areas are. So here is the actual Mechanicville hydroelectric plant. That's on its own part of the dam. In theory, it's a kind of a museum. I would love to get a tour in there. I just don't know how you do it, or I know that they offer them, but I don't live in the area, so it's kind of hard to be there. By the way, just remember, I used to make this mistake a lot. It's Mechanicville. I generally try to go to Mechanicsville, as that's typically the more typical name. There was also a number of more spillway equipment. The dam, the thing for this dam to be able, most of the hydroelectric dams will have their own little gates before each of the penstocks, and they'll have some sort of crane there to be able to do it. So this traveling crane goes back and forth on the crane rails, and it will pull up and down the things to get the stuff flowing. I'm not sure if it was on the same day where I did the trip with the Atlas silos, just at the end of the day, or if I made a separate trip. So, I'll get back to it, but the Mechanicville hydroelectric plant is the oldest operating hydroelectric facility, I believe. It's not in the United States, in the world. I have to double check that. It was what is it? Hold on. It was built in 1897 and has been operating continually since then. So this is definitely on the very forefront of electricity. New York was the home of Tesla and Edison. General Electric is Schenectady. This was the Silicon Valley, but it was more like the copper spinning magnet valley of the United States at the time. It started as a 38 hertz facility. I think it's been converted to 60 at some point. It used to have motor generators. But just remember that it's. Trying to think here. Yep, General Electric made it. Although I think the War of the Currents was largely over by 1897. It was part of an early HVDC system to power the GE plant. There's a number of GE facilities in the area. I think it only got off. I'm not sure if they ever. And for all I know, it could still be doing 40 hertz and still needing a frequency changer. I don't know. I haven't seen it. The current rating is 5 megawatts for all the turbines. They're all sub-megawatt. But I don't want to. I'll have better photos. I mean, again, I didn't get inside, but I'll be able to talk about it a little bit better in a bit. Oop, that's the end of the first bit there. I made sure to do a little bit more prep today, so we have less dead air. Yeah, there's a lot of neat old. The United States did try to get some amount of canal infrastructure going. The main line of public works, of course, in Philly, the Delaware Canal going up to Easton, the Morris Canal between Easton and New York. Again, a lot of it was for coal. The Lehigh Canal to get coal to Easton from the Lehigh River. The Raritan Canal from Trenton to New York. These are the big ones. I know that there was a canal along the Connecticut River. The Susquehanna River had a canal. Then, of course, that turned up to the Judiana River to try to get over the Alleghenies. That was going into the 1850s, right as the canal. If you remember the Johnstown flood, the dam that broke, that was there for the Pennsylvania Main Line to Public Works Canal. I already talked about the Erie Canal, so I don't need to reiterate on that one. I don't know how far. Yeah, I think Delaware only really went up to the Easton-y area. There's maps of all the stuff, but those are the big ones that were really going on in the Northeast. And they're almost all of them, unlike the UK, where the canals just go all over the place. They just dug them out, viaducts all over the thing. And the United States canals really only followed the rivers unless they absolutely had to cut across between to cover the gap between two rivers. We did not have that type of canals all over the place like you saw in the UK. That was, we definitely try to minimize letting the canals stray from the river. All right, and here we can see the lock chamber for the canal. In this case, it's not cut into the earth. It's almost a standalone structure. And here is sort of the reserve spillway. So you have the main Lowhead Dam, the lock. You got this waterway here, and then the hydroelectric plant over there. And there's the bridge accessing the canal. And like I said, we weren't sure, can we go over here? We were walking around. This is the same type of thing. Just like the guy who came out of the missile silo and was nice. The guy who came out of this place and was super nice to us. It was the tender. And I think that just this time of year, in this part of the canal system, he just didn't have a lot to do and was perfectly happy to talk to us. So the neat part about this one, as he explained it, was that this was one of 2 or maybe 3 canals locks that still used their original hydroelectric or had intact and had usable their original hydroelectric gear to run the canals. So when these were built, they had on-site power generation because in the 1920s there was no power grid. I've said this before in my railroad videos. That's why railroads had to be their own utilities. No power grid. So each of them had a powerhouse with 2 hydroelectric turbines that would then provide power to the electric motors to open and close the lock. And as you can see, they've done an absolutely, the guy or whoever the people are have done a fantastic job keeping it shiny and nice. I forget which Erie Canal locks also have it. This is the only one on the Champlain. Erie also has 2. If I can remember properly, it's like lock 7 and lock 13. But I'm not. Don't hold me to that. I'm trying to remember something that this is turbine number 1 with a little thing there. I'm trying to remember something that a guy told me in passing 15 years ago. Incidentally, these were idling, but they weren't in use. So there was enough water going through it that these would idle, but there was no excitation. It wasn't generating power. So it's like when you have a box fan in your window, and the what is it? You put a box fan in your window, and the air currents make it lazily turn. They're not really doing any work. It's just they would just hear. In fact, I have a video of it. It's on my Wikipedia, not Wikipedia. It's on my YouTube channel. I can put the link in the chat if you want. Of these things idling. I'm sure that to actually get them going requires syncing them and all sorts of steps. So here we have turbine 1 again. There's probably a main valve. The governor is right there behind it. I don't know what that equalizing tank is behind it. The governor is next to it, or also behind it. Sorry. Governor is just basically a thing using weights. I'm pretty sure that's what that is. So it will turn and it will be hooked up to there. So as the rotation increases, there's something in there that will then meter the flow of water, so the turbine doesn't run away. That's generally the biggest concern, not about the amount of power it's drawing, but you don't want to have these things increase in RPM to a point where it gets damaged. Would have loved to have had this. Again, this is one of those things that I, predated my phone by a good 8 years. Here you have both of them. There's number 1 and number 2. I'm betting that you could run all of everything you needed on one. So there was one that was going to be the live one, and there was going to be one that was going to be the backup. Here we have the old switchboard. This, again, original to it, very 20s. It's going to be mounted on slate. I'm not sure what that is. That tops out at, that looks like going to be your voltage. Maybe your RPM is topping out at 300, 350. That looks like amperes. That might be cycles, or there could be 1 ampere thing per. I'm not sure. No, this is under the hundreds of amperes, so that's probably going to be your frequency. And then a whole bunch of wonderful knife switches. Really cool, and I'm sure it's made by General Electric. Construction of powerhouse. No, it's not a GE. It's some independent operator. Here we have. Now here's stuff I'm not entirely sure what's going on here. That's clearly the thing to the right is a speed governor. These are other motors. I don't know what they're doing. That's the little manual motor controller for them. They might open and close something. I really don't know. That could be maybe an electric governor, that these are spun based on the RPM. I guess the thing in the brass tubes is water supply. Really don't know on those, but it's really really cool. Kept to a very high standard. They're called sync motors. That could be they do something to help synchronize the tower turbines. I think you can see how this goes. So there's a governor. There's another one behind it for the other turbine, and we have these two sync motors that will probably one for each. That's good. So now we're in one of the motor control houses, and again, it's all the original. I don't know what's on the other side of this thing, but like this is definitely a little quirky. No, this is not a printed circuit board. This is a very. Who says this isn't solid state? This is the most solid you can get. That's the most solid thing ever. This is again as part of the motor control system for the door. Not entirely sure how it is or what's in the back of that. It's probably a bunch of resistors and crap and relays on the back side of the other of that. So yeah, it's the gate motor controller. I think that's the gate motor. Remember how I said that it works through a clutch? Yeah, this is the gate motor. That's the gate motor controller, governors and stuff, and then there's the gear, the incretion gear right there. Or reduction gear, I should say. There's your resistance, right there. So that's what allows for your motor control. It's a DC motor with DC resistance control. To get the thing to spin it up and down, you cut in more resistance. Looks like a big old toaster. This is exactly the same type of stuff you see in a street car. That's why I'm not shying away from doing this thing today, because so much of this is exactly the type of thing you'd see, in early rail DC rail transit type stuff. Sorry, just fiddling around a little bit. I'm using plus sizes for these, just so people can see detail. I'm just trying to get the whatchamacallit, the size in place. Okay, yeah, here's what's on the other side of that. Oops. Ah, crap. Damn it. There it goes. This is what's inside the thing. It's some switches and some motor control relays. Really, really cool. See myself and my friend. My friend was currently in school at RPI at this point in time. So we've got at least 4 relay groups and some switches, some sort of governor maybe. I have no idea. There's a lot of neat stuff. Again, this is beautiful. Look, it's a wooden box. Everything's shiny. Gosh, I hope that some short-sighted administrator didn't come in here and rip this out, because this stuff is so neat. So neat. And if you're anywhere near there during the season, like if I'm going to definitely put. I'm only there in the winter now, but if I'm ever there in the summer, I want to come out here and poke around and see if I can get another in-depth tour. Maybe you can get to see some of this stuff get used. And then here is, it's like so what does the motor controlling? Well, some might assume that it would be some dude, sitting, like a guy working an elevator, an old elevator. But because the doors only have 2 positions and they have a sequence controller on a cam. So as it starts to move, they want to get the door, it starts to move. And in certain parts of it, well, here, these cams, like, it'll first cut in and at the lowest, at the lowest RPM. Then it will get going a little bit fast. As it goes to a certain point, it'll take out resistance. The motor will go a little bit faster. Then as the cam rotates and it completes its travel, it will slow down and then stop. And you see this exact sort of thing in electromechanical relay controlled elevators. The floor leveling in here's your word for the day. The act of an elevator or an automated train system, I guess for a train you call it platforming, but for an elevator, what they call it when it slows and stops and the door opens and it's the right place, that's called leveling. And the way on a pre, microprocessor controlled elevator is that you have an analog. Like this when I say analog control. What does analog mean? It's an analogy. Analog means analogy. This is an analogy for the position of the door and what the thing should do in built-in physical situations. So an elevator will have a little model of like the entire building, like the entire its run of travel. It's all the floors, and the thing will spin around, and it will cut in certain relays at the appropriate time, usually with a little shuttle going up and down. A little model of the elevator, replicated as a little thing going up and down, or a rotating sphere, all sorts of stuff. And the same, unlike an elevator where you have buttons and calls and stuff, this only has 2 positions, so it's pretty straightforward. The way that I can make a technology connection to trolleys and stuff is if you're ever on a streetcar and with the guy, that console controller at the end, that stand where the streetcar operator it has a crank on the top. This is what is inside that whole stand. It's fingers and a shaft. But instead of it only needing 2 positions, you've got a human operator working this bit here, the bevel gear part. So here it's automated, it's automatic, but on a streetcar, there's a guy holding a lever, and he's working the same thing you see right there. And that's cutting in the various resistances, making it go series, parallel, maybe shunt, probably not. And it's up to the human to cut those in such a way that you get smooth acceleration. Later, whatever, the human, the operator would command would ask for an acceleration rate, and that will use a pilot motor again to cut in and out the resistances in a sequence. So here are just, a low light thing of there. So here we have the canal lock right there, and then there's the Mechanicville hydro station. Today you can generate the same or more power in a very compact building. I will, as we transition to hydroelectric plants, we'll go up the river 2 miles to the next one, Lock 3. So that building right there is the Lock 3 power plant, Upper Mechanicville. This is 16.4 megawatts of power built in 1983, I think it said. It's just a boxy building. I don't know how many turbines it has, probably 2. But that's triple the amount in Mechanicville for, I don't know, a third of the space. Just shows you the progress of, a century of progress in just turbine and whatever design right there. Pull this up here. Almost done with our stuff. We're gonna have one more short set after this, and that'll be it for this section. I'm actually gonna have a bunch of 2000. If I ever get into I'm getting close to doing 2008 here. I do have a variety of what I call like one-nighters in 2008, so that will be super useful for scheduling. That's weird. Google trying to pull up another thing of Google Maps and load all the photos at the same time made it choke itself. Yeah, as you can see, we are going to end with some actual rail content, so have no fear. My point was to show the newer building from Street View. So there you go. There's your modern hydro facility. Same gantry cranes at the penstocks on crane rail. No industrial park, stuff like that. So that just shows you the new, 16 megawatts in that size of a building. Whereas at Mechanicville, you have a giant building for a third of the amount of power. But we have one additional. So here we have the Lock 2 powerhouse, you can see from here. I don't know where the water enters, how it exits when it's actually running. I think that it's out the side there. As you look around, you'll see these similar buildings at other. I was at the Erie Canal, like Lock 5 or 6, earlier in February, and I saw the same building. Like, I should go check that out. And I went over there, and they were just, it was a workshop, but there was no, there was no sign of the old powerhouse, no sign of the old equipment in there, unfortunately. Oh, interesting. No, I'm actually for you fans of the channel. I'm not sure how many people are. Oh, I should probably check to see if we have any stuff to see here. Yeah, no, I'm actually going to be this guy is on its I'm actually in the midst of a PC refresh. So this is the one that lived at my parents' house, or still lives at my parents' house. Part of the reason I do this on here is because, like, I never needed a big and powerful computer to go through especially the older stuff. It does it does two things, but it's getting increasingly bad. But the same thing is, I'm going to be bumping down. I bought a new computer. I'm in the process of building it up to to match my workflows, and the one I'm currently using is going to then tumble down to this place. And this one is going to go and get retired to a degree. I forget how many turbines it has. 6 or 7, I think. I can check here. I don't think it says on the Wikipedia page. Oh, right, here it is. 500 megawatts, 5 megawatts, 7 hydraulic, 7 turbine units. So you can actually see that they're still there. They're painted yellow. They're the same type one, the same ones in that photo. See, big old spinning wheel. We go to the Wikipedia page, and where is that? Yeah, same exact stuff that's still there. Been in service going on 110, 20, 125 years. Really cool. If you're, again, I don't know what you do I don't know how the tours work or whatever. It's one of those things where if you're part of an engineering society, a lot of cities will have them. They can arrange some really cool tours. I got a couple. My friend was involved one briefly in the Baltimore area, and we got a tour of the trash to steam plant, the tunnel, the Baltimore tunnel vent plant. A lot of neat stuff. And here we have the substation on a very cloudy day. I have been back. I have on my Wikipedia page. I have some videos of zooming through the windows of the turbine spinning. Nothing super fancy. And finally, we are on the Northeast Corridor. So this was getting near the point when Union Tower was on the road to decommissioning, so I was then taking extra steps to try to get back of the train photos, which you could do back then because business class was the first car of the train, not the back. Okay, well, this is signal 170, 17.7. Okay, so I'm just going to... So this is on the 6-track raceway between Elizabeth and Rahway. Fun fact, in the around 1906 when Union Tower was built, the PRR was actually in the middle of... had a plan to 6-track the NEC from New York to Trenton, with the extra 2 tracks being freight priority tracks due to just congestion at the time. They built part of it between Rahway and the curve at Elizabeth. I'm trying to find where my thing is for North American Towers. Huh. That's strange. Alright. Whatever. So anyway, they what is that? They started in World War I. It's one of those things like the war happened or something, and they just never got around to finishing the project. They electrified, and they didn't need to do it anymore. But it's a shame. Oh, there's Union Tower, but I just want to get the diagram going here. So Union was built in... they usually tell you. Guess not on this one. But anyway, this is the milepost 17.7 intermediate signal covering 6 tracks. But the outer 2 are Rule 251. Wait, hold on. Yeah, the only rule bidirectional tracks, I believe. Now these aren't entirely things. I think everything's bidirectional except the outer ones, but I could be wrong. It could be only still the 2. It could be 4 251s and 2 261s, but I suspect that it's 4 261s and the outer 2 are still Rule 251 ABS. Today, if you're on a miserable, if you get unlucky, you will find yourself on track A or track B. They're not numbered; they're lettered. Here we have. So this is another thing you don't see anymore. I'm pretty sure that this is a revenue move and not a Amtrak NJT will run some really weird contests down the NEC because they have a wheel mill at Morrisville Yard. So you'll see like, a Jeep towing an electric, towing a passenger car, towing another electric, all sorts of weird like moves, and they will shoot down usually in the PM, like 8, 9 o'clock at night, blitzing it down to Morrisville. But this is, what this is, I'm pretty sure, is what they would call a diesel. There was a certain number of trains coming off the New York and Long Branch before they got to dual modes that would run express to like Hoboken or to Newark without the power change, and they would call them diesel expresses in the timetable. I think that's what this is. 4146. is one of the GP40PH-2As that got retired. They're still using the -2Bs, specifically on the Atlantic City line. The Erie Heritage unit, the 4200 series are those. Behind it is the old part of Union Interlocking. Union was divided into 3 locations. The first location is... Oh, it's not even on the map. That's weird. First location is all the way down there, where track A turns into track number 1. Or maybe that's track B. Hard to tell on this. Okay, regardless of which one is actually track A and which, I think that the top one is track B. So today we have Union, which is all this stuff in the middle where you have the flying junctions, the famous NEC flying junctions. You have another one all the way down this way to the left, off screen left, where track B turns into track 4. And then over here you have this other thing, I think it's called Merck, where it serves with the old Linden Yard. It's specifically Merck Pharmaceuticals, and that became its own interlocking there. But here it's still part of Union. So you have the 18 automatics, and then at the far end you have the 38L switch. But I'm actually kind of burying the lead because really, 4146 should be celebrated. So I'm going to switch the name around. 4146. And then go to the diagram and get the numbers of the autos. So it's going to be the 186 and the 187 automatic. 186 clear and 187 rear. Those are only on the Linden tracks. They're what do you call it? Slower and designed for higher density. Here we have the famous Linden gantry lever. Gantry levers are a combination of a signal bridge and a cantilever. This is 3 tracks. This is after the signals had been replaced. That's why you have the round bottom targets on the bottom. One of the reasons I was looking to start getting more photos of this. Fun fact, Linden, maybe just go down to find it. There it is. There's the old Union. So like I said, the old limits went all the way up here to the Merck yard. There's the big Merck plant. Boy, that's big. There's Rahway Station. Today it's known as having one side platform and one island platform, a very wide island platform. Probably lets people connect easily. Fun fact, you can still see it. It had 2 island platforms, which is pretty neat. I don't know when they took it away, but you can still see where the access stairway is right there. So Rahway did in fact have 2 island platforms. Ugh. Here we have Union interlocking its core and Union Tower right there. They are in the process of they're in the process of reconfiguring the interlocking. You can see the old way, this used to have an equilateral turnout between right there and there, and they made them into two not less equal. So there's your equilateral right there. It's not any faster, it's all medium speed. But apparently because they can't equilateralize these palletized concrete switches, Amtrak converted it into two typical turnouts. So there's your old equilateral, and there's your new style right there. On the diagram, you can see how they're both in this Y configuration, there and there. That's going to be the 1517 switch and the 2119 switch. Let's see if they switch them both. So, I'm trying to find out where these come. There it is. He comes up. He has that's going to be a 45. That's a number 20, and the same thing happened there. Yep, they realigned it. This, I'm not sure if that's a number 20. That still might be a 15, although it only has 1 point machine. Could be still be a number 20. But that's definitely a number 20 right there. The number 20 is the higher the number, the easier the switch. A number 15 is typically 30 mile an hour. A number 20 is 40 mile an hour. Like a number 37 is going to be your 80 mile an hour. So yeah, this is after they realigned the first one and before they realigned the second one. And for reference, that is going to be the 16LA Dwarf. Really nice photo here. I mean, it's not a nice technically nice, but it's nice in terms of, I didn't quite realize what I had here. This is a very, very nice point of the thing. So we have the Union, the 6LA, I believe that's what that said. Correct. It's the 19... A little brighter? Yeah, I can make that a little bit brighter. So here's the part of Union that went bye-bye, mostly, was this really cool inner signal bridge. This is the it had a older interlocking, especially with towers, would often have more signals. This would keep the interlocking logic easier to manage if you had more signals on an electromechanical type machine with levers running all the way down. In modern ones, this was considered to not be necessary. Also, you can see how that dwarf is going to get subsumed by a high signal, possibly expanding the amount of Rule 261 north of Union. That would be the 4. Trying to think if there's anything else on this track. No, that's going to be the new 4N or 4E signal. And I can say that track 4, 3, 2. So track 2 is stop and proceed. It's displayed. It counts. And the last thing of the day. Nope. What is the last thing of the day? Looks like one that I cut, but I'll bring it back. This is going to be the 39 switch, and right over the westward, the westbound duck under, or plus the eastbound duck unders. Oh, you can see both duck unders right there. North Jersey coastline. Cool. Got one back from the dead. Great. All right. Well, anyway, I'm going to just wrap this up, see if anybody has any questions. Oh, here's a video of the Champlain Canal hydro thing spinning. It's going to be a pretty bad video. But you can try to see it if you can. I'll make it big. I don't know what I'm how this is going to look in the stream. Yeah, you see, it's just sitting there. Some people might assume that it was on, but the guy said it was just spinning idly. Very echoey in this room. Okay, let's see if anybody has any questions. Yes, the 6 tracks are going to go at least all the way to Trenton, and like at least to Trenton. It's basically because if they got them to, it's like you have the old Trenton cutoff. And I can zoom out here and take you to the line diagram. So their plan was to have 6 tracks go from like the freight hub in New York all the way across New Jersey, and then they could have the freight trains go directly onto the Trenton cutoff and out to the main line. So it's going to be, it would have been like a prototypical, what Conrail actually became using the Lehigh line, melding into the CNJ, melding into the Reading. But like I said, they started it, they built like 10 miles, and they built it where, they didn't want to cut it through Elizabeth yet. So they just did it where they had, they could, but it just sort of never really materialized. The right-of-way is 6 tracks. I think they actually bought a lot of the right-of-way for those extra tracks. Or you can see it in places. So everything collapses to 4 tracks by there. But you can still see there's a whole chunk of track like right next to it. And it was going to be basically 4 plus 2. So see all these houses with their big backyards? It would have gone down there. It was going to be next to the existing line. So you would have had 4 tracks with the existing main line, and then it would have had 2 additionals next to it. I'm not sure where else you can find any evidence of that. I think maybe more in Central. Or sort of like right in here, maybe. I don't know. No, it don't work. I just get a lot of documents from a friend. Yeah, so you will see just deadheads going by Princeton, but I'm talking about you'll see all sorts of weird stuff of like random locomotives shooting down past there to go to the wheel mill. So just remember when I say number, whatever switch, that's not the lever number. I'm switching things there. So you have like the number 17, that's the lever 17 switch. It's a number 15 turnout, a number 20. That's just how you. It has to do with the rise over run type of thing. Like the ones you see on transit systems, those are like number 8. The ones that will get you 15 miles an hour on a transit system are like number 8s. The slow speed ones on a railroad are number 10. Medium speed is number 15. Limited is 20. There's one that's like a 20. There's one that's up. There's like a 60 mile an hour one, and then I think that the full high speed 80 mile an hours are number 37. Number like 35.7 or number 37.5. The rule of thumb is kind of that you double the number to get the speed, but it doesn't quite work out. All right, I think that's everything. Thank you so much for tuning in. I will see what I can do in the future. I have a whole new bunch of things to do. I want to finish up these 2017s, but the ones that are coming up are going to have a lot of stuff with them. The Mineola one is likely going to be the next one that I tackle. I can do it in 3 nights if I have them all together or not. I did the Harrisburg one. Adirondack Dome car is another one that I want to do. That's where when Amtrak used to run the Dome car on the Adirondack. I got photos from that, and I think that's going to be. I'm just checking them right now to see how many I'm going to have on that one. Oh, that's what's causing the delay. It's trying to open a video player for some of these. Come on. Here he goes. Yeah, so I think a bunch of these are going to have cuts. That's where basically it has non-railroad content I can cut out of it. So, yeah, there's a lot of cuts in this. So I think that this will be, what number is that? 193. Dome car stuff. More dome. Yeah, so I'll go through this one and just see how many I'm actually going to have to do on that. Oh, Renaissance Fair crap. Yeah, I got a whole bunch out of this one. So the Adirondack Dome car and the Mineola trip are definitely going to be strong contenders for the next ones that I do. All right. All right. So you guys have a great night, and I will see you next time. VLC has its issues. It does take longer to load up. Again, the major issue is just this computer, and I'm going to be replacing it. My cutover date, I'm hoping, is going to be Memorial Day weekend. They should be able to finish the last bits and do a full cutover of all the data. All right? Have a great day. I'll see you. Bye.